it's Reese and welcome to your first chapter on number sense. Well, it's your first chapter and it's your first chapter on number sense. Hey. Now we're going to start with patterns. And here's the definition. Well, here's some stuff about length. You can use almost anything to measure length. If you remember grade 2, you used paper clips to measure pencils. You used erasers to measure rulers. Wait, no. More like erasers to measure pencils. You just use a lot of unconventional things to measure things in grade 2, along with the conventional ones, such as rulers with inches and or centimeters. Now, length is the distance between 2 points. These points can be on a piece of paper or an actual distance in real life, such as from one city to another. Now, back to patterns. When looking for a pattern, see how the next number changes, which is basically they're telling you to find the distance between the number and the next number. So the first pattern we have here is 1, 2, 3, 4, 5. Everything's just increasing by 1. Or getting bigger by 1. 1 plus 1 equals to 2, 2 plus 1 equals to 3, 3 plus 1 equals to 4, 4 plus 1 equals to 5. And the second pattern has 5, 10, 15, 20, 25. Now everything over here is increasing by 5. 5 plus 5 is equal to 5. 10 plus 5 is equal to 15, 15 plus 5 is equal to 20, and 20 plus 5 is equal to 25. So now let's do some practice problems. Identify the pattern, then find the missing numbers. The first one we have here is 4 something, 12 something, 20 something. Now you might be wondering, I don't really have the next number. How do I figure out what the next number is? Or, well, complete the pattern by filling in the missing numbers. You see, 4 to 12, there's a gap in between, and so the distance from 4 to 12 is plus 8. The distance between the third term, which is the third number of the pattern, and the fifth term is also plus 8. But since there's something missing in the middle of both, the second term and the fourth term, well, you'd see that, what's half of 8? 4. Now, would this make sense? 4 plus 4 equals to 8. 8 plus 4 equals to 12. 12 plus 4 equals to 16. And 16 plus 4 equals to 20. 20 plus 4 equals to 24. It seems that we have found the pattern, which is plus 4. And since we didn't really have numbers right next to each other, or consecutive terms, if you really want to use fancier mathematical language, we opted, or we chose, to use terms that, well, we're as close to each other as possible, and factor in or consider or actually think of the terms that were missing. Because there was a term missing in the middle of both of these, plus 8s, then, well, since it's in the middle and it's not a one-time thing, then 8 divided by 2 should be the rule of the pattern, which is plus 4. Think of it this way. So the patterns that you're learning right now are relatively not that hard. Compared to the ones that you end up learning in high school and stuff, no, they're not the worst. If you want to use high school language, they're linear, which means that they increase by the same amount each term. Or decrease. So think of it this way. You have a fence, and the distance between the two fence posts is 100 meters. I know that's not how fences work, usually at least. The pattern for this fence is, well, this hypothetical fence, imaginary fence, is supposed to be that the posts are 100 meters away from each other. But then they decided, let's add another post in. So where's the missing post? And since patterns that we're learning right now increase or decrease by a set amount each term, then they're going to have to put it in the middle. So we're going to have the 100 meters, which then becomes 50 meters. So that was the logic behind this. Now we're going to continue to 11, 18, something, 32, something, something. Okay then. We have 11 and 18 right next to each other. Now, 11 and 18, what's the difference? 11 plus 7 equals to 18. So what's 18 plus 7? 25. What's 25 plus 7? 32. What's 32 plus 7? 39. What's 39 plus 7? 46. The pattern rule is plus 7. When trying to find the pattern rule for these type of patterns, which, well, increase the same amount for each term number, because yes, there's patterns that don't do that. You simply have to do subtraction. Especially if, well, there's two terms that are right next to each other. If it's something like this, though, you might have to do some division. Which is why, in grade 3, we start learning the multiplication table. Moving on to the third question. 300 to 260. Okay, then. It seems that this is a subtraction type of relationship or pattern. So 300, subtract what equals to 260? 300 subtract 40 equals to 260. So our rule so far is minus 40. Now what's 260 minus 40? 220. Now what's 220 minus 40? 180. Well, that fits. So it probably is the pattern rule, especially since we're only doing linear patterns right now, or patterns that increase or decrease a certain amount with each term. 180 minus 40 is 140. 140 minus 40 is 100. Yay! Now we move on to question number 4 and 5 and 6. Okay then. 20 something something 14. Well, this is troublesome. Here's the thing. It's 20 something something 14. So what's the difference between 20 and 14? 6, right? So there's 2 more fence posts in quotation marks, in the middle of these 2 numbers, which divides the difference or the distance, length, between the 2 numbers, technically it would be distance over here, into 3 parts. Also, this is also why we remember our multiplication table, because multiplication and division are opposite operations that are paired together, just like addition and subtraction. It's kind of difficult to learn one without learning the other. And by one without the other, I mean you can learn addition first. That's what you usually learn first. But right after that, you're going to learn subtraction, and then you're going to relate it back to addition. It's the same thing with multiplication and division. You learn multiplication first, and then you learn division, but then division is based off of everything from multiplication. Anyhow, what's 6 in 3 parts? Hint, hint, guys, it's 2. Therefore, we're going in 2's. We're going in which direction in 2's? Well, we're subtracting because 20 is bigger than 14. So 20 minus 2 is 18. 18 minus 2 is 16. And 16 minus 2 is 14. It seems like that fits. So we're going to put it in. Now what's 14 minus 2 for the last term over here? 12. Yay! Oh. 32, 82, something, 182, 182, something. So we have 2 terms that are right next to each other. 2 consecutive terms. Consecutive means a number that comes right after or right before the other number, such as 1, 2, 3, 4. There's also consecutive odd and consecutive even, but usually you don't concern yourselves with that in grade 3. Now 32 and 82. 82 is bigger than 32, which means that the pattern is increasing. But by how much is it increasing? Well, 82 minus 32 is 50. So it's increasing by 50s. To test that, we add 50 to 82, and we get 132, 132. And then we add 50 to 132, and we do get 182. Therefore, our pattern rule fits in with all the given terms. And now let's find the last missing term. 182 plus 50 is equal to 232. Now I'm going to write down the pattern rules. Plus 50, and oh yeah, for this one it was minus 2. Now we move on to question number 6. Each student in the class has a rock collection. Alright. I mean, okay then. If the pattern continues, how many rocks will Everett and Fatima have? Okay, so Andy, A, has 5 rocks. Beatrice, B, has 7 rocks. Colette, C, has 9 rocks. And Daniel, D, has 11 rocks. Our term number is, okay, I guess it's just going alphabetically. So, what's the pattern here? 5, 7, 9, 11. Well, 5 plus 2 equals to 7. 7 plus 2 equals to 9. And 9 plus 2 equals to 11. It appears that our pattern rule is add 2. Now what's 11 plus 2? 13. What's 13 plus 2? 15. Everett will have 13 rocks, and Fatima will have 15 rocks. So we're done that, and now we're going to move on on to the next section, which is a problem-solving strategy. But on a side note, if you want to take a break, do so. Feel free to take a break at any time during the video. But if you don't want to take a break, or you just came back, hi! This is section 2. The four-step plan. So the four-step plan is a plan that subconsciously goes in, well, everybody's minds. Why? Because every time we read a question, no matter how much time you've spent doing math, you technically do all these 4 steps. Step 1 is understand. Step 2 is plan. Step 3, solve. Step 4 is check. Here's how we do it. We start with reading the question. Carol's game piece is on box 38 of a game board. She moves it ahead 15 boxes 2 times. Wow. Where is her game piece now? So we read the question and we think, well, what facts does the question give us? It gives us where Carol's game piece currently is, how much she moved it, and that's it. So what do we need to find? What is the question asking us? The question is asking us well, you see, usually there's a question mark on the question, so that's a really good place to start. Hint, hint, right here. The place with the question mark says, where is her game piece now? So what do we need to find is what does the question ask? Now, our plan for now is math. Because, well, usually, I say this a lot. I'm probably going to end up saying this a lot. If you watch any more videos, then I'm going to say this many more times and drill this into your head. Acting it out, I know that some people learn better by acting it out. I have no problem with that. It's just that you can't solve all your problems by acting it out. You could learn the concept by acting it out, but you can't solve all your problems by acting it out, because that's the one thing that they don't allow you to do on tests. And I know that a lot of countries are focusing more on projects, but this is math. Math, my friends. Math. It's almost impossible to never have a test in math. And usually, if the teacher never gives you a quiz in math, or a test, I've seen that happen before. That class was an absolute disaster. Now, drawing a picture is also a common strategy that they tell you to do. Drawing a picture is also okay for initial understanding, because some children just visualize better. I'm also aware that some children cannot visualize. But drawing pictures takes a lot of time on a test. Therefore, the best way to go about doing questions is just math, as in number sentences, algebra when you learn it, and all of that jazz. Of course, if it's a geometry problem, then you're probably going to have to draw a diagram somewhere. In fact, if it's a graphing problem, which is part of algebra, you're probably also going to have to draw a diagram somewhere. But for stuff like this, it's better to just resort to good old math. Now, we have her initial position, or where she starts at, and she moves 15 boxes twice, which means that it's increased by 15 twice. Now, this is once. 5 plus 8 is 13. Regroup. 3 plus 1 plus 1, 5. That's a 5, guys. And then that plus 15 again, which is a second time. And we get 3 plus 5, 8. 5 plus 1, 6. 68. She is now on the 68th square. Her game piece is now on the 68th square. Now we check. Sometimes the teacher will ask you to explain why your answer makes sense. Usually in math, that just means talk me through your process and why you did everything in your process. Here you would say something like, so since she moves her game piece forward by 15 squares 2 times, then we need to add 2 15s on, well, no, not 2 15ths, that's fractions, 2 15s onto her initial position. Or we need to add 15 twice onto her initial position. Her initial position happens to be 38. Therefore, we added 15 to 38, got 53, and then added another 15 to that. Check your solution to make sure it makes sense. Well, I mean, usually you just look over your calculations. Sometimes you redo the problem if you have enough time, and all of that. It seems that our calculations are correct. You would usually also go back to the question and reread it just in case you missed something. Or you read, say, 42 instead of 38. I've seen that happen before. It was not a very pleasant experience for anybody in there. The teacher would probably look at the paper and go like, oh wow, this is not a high quality mistake. And then the student would look at it and go like, how did I make this mistake in the first place? Yeah, read the problem properly, kids. Carol's game piece is on box 38 of a game board. She moves it ahead 15 boxes 2 times. Where is her game piece now? Well, we got our facts straight. So, our answer should be correct. We're going to move on to the next section. Now, section 3 focuses on place values through 1,000. The English system for place value is actually a lot less complicated than you would think. Now, we start with writing numbers in expanded form, standard form, and word form. The motto shows 1,378. The expanded form would be 1,000. Fun fact, not everybody actually uses a comma. So, in 1,000 and bigger numbers. Plus 300 plus 70 plus 8. Essentially, it's a breakdown of every single place value. How many thousands there are, how many hundreds there are, how many tens there are, and how many ones there are. Now, standard form is just the stuff that you've seen on papers. 1,378. Word form is how you would read it out. And not, say, in numbers. It's always written in words, which is, well, letters. And it's also very tedious to write, because 1,000 300 78. Here's the thing, though. Somebody may say 1,378. Somebody else may say 1,378. Somebody else may say 1,378. The ands and the placement thereof are very much debated, for a lack of better wording. Now we're going to do some practice problems. Look at the motto and write the number in the three forms. So here in the motto, we see that we have 1,000 cube. This is 1,000 cube. 100 block. For 10 blocks and 1, 2, 3, 4, 5, 6 1 blocks. Now as you can see, the 10 blocks are made out of 10 1 blocks, the hundreds block is made out of 10 10 blocks, and the thousands block is made out of 10 100 blocks. First we're going to write down the standard form, which is 1,146. The expanded form would be 1,000 plus 100 plus 40 plus 6. What about the word form? Well, we kind of just set it up here. All we need to do is write it out. 1,000 146. We continue to the next problem. There's no thousands cube, so there's nothing in the thousands place. But there's 200 cubes. That's 7 tens cubes. Well, not cubes anymore, blocks, let's just call them. And 5 ones unit cubes. We get the standard form 275. 275. And the expanded form will not have 1,000 because, well, there isn't 1,000. It'd just be 200 plus 70 plus 5. The word form will also not have 1,000 because, well, you wouldn't read this out as 0,000 something something, because if we read out everything that was every place value, that's what I meant, that what didn't exist in the number, well, you see, there's a reason why infinity is a thing. Because numbers can get large for, well, infinity. Which means that we only talk about the place values or the digits that are actually there. 275. 275. Continuing, we move on to the last question of the section, where we have 2,000 blocks. I'm very tempted to just call them 1,000 bricks. Technically they're cubes, but then again, bricks can be cubes. So we write 2. And then we have 100 block, and that's 1. But there's no tens blocks. So for the tens place, we're just going to write 0. And then there's 1, 2, 3 units cubes, or unit cubes. And that's, well, we have the standard form now. 2,103. Okay, guys, some countries, they don't use the comma. Some countries, they use something else instead of the comma. And honestly, it depends on your teacher, but a lot of them won't actually care if you use a comma or not. Unless it's an extremely long number with no decimals or with very few decimals. Okay, moving on. What's the expanded form? Well, for the expanded form, we have 2,000 plus, there's 100, that's just 100, plus, there's nothing in the tens, so we skip that. And we move on to the ones, and ones is just, well, 3. Yay, that's our expanded form. What's our word form? Well, read it out. 2,000 103. Here's the thing. I know that I've said that the use of and in place values is, well, it's different for every person. But usually if there's a 0 in the middle of something, then you say 103 in this example, or something something and something. Say it's, well, actually I can't use this example because we're going to move on to the next section and learn about that example. Place values through 10,000. You can use a chart to find the place value of each digit in a number. So, the number that we're given over here, we have the standard form, which is 36,815. Now I'm going to teach you, well, actually show you what the place value chart looks like for this. We have 10,000, 1,000, 100, tens, and ones. For the ones place, there's a 5. For the tens place, there's a, well, 1. For the hundreds place, it's 8. Thousands place, 6. And the next place is 10,000, where we have a 3. This is what 36,815 looks like in a place value chart. Now, why do we call this 36,000? Well, you don't look at the tens place and the ones place and say 1, 10, 5 ones. So you wouldn't say 30,000, 6,000. You just put them together and say 36,000, like how 1 10 and 5 ones is 15. We move on to the expanded form. We start with the largest place value, and we get a 3 in the 10,000s. So we get 30,000 plus, and then it's 6 in the thousands place, so 6,000 plus 8 in the hundreds place, 800 plus 10 in the tens place, 10. Well, actually, no, 1 in the tens place, and 1 times 10 is 10. Or, since you haven't really gotten to multiplication yet, 110 is just 10. And in the ones place, it's just a 5. Whew, I'm going to have so much fun when teaching you guys multiplication. Anyhow, moving on. So we're going to have to write the number 82,957 in the place value chart. Then write the number in expanded form. So for the place value chart, we have 7 in the ones place, 5 in the tens place, 9 in the hundreds place, 2 in the thousands place, and 8 in the 10,000s place. You just fill it up and make sure that you don't put everything in the wrong place. Like say you don't put 7 over here and 5 over here and 9 over here and yeah. So the expanded form, we look at the place value chart and we get 8 10,000s. So that's 80,000 plus there's 2 thousands, so that's 2,000 plus there's 9 hundreds, 900 plus there's 5 tens, 50 plus 7 ones is just 7. Well, that's that. Now we write the value of each underlined digit. We have 69,251. The underlined digit is 9. It's in the thousands place, so the value is thousands. Or technically 9 thousands. Now the value over here is, it's underlining the 5. The 5 is in the tens place. So it's 5 tens. Question number 4, the number underlined is a 6 in the 10,000s place. So that'd be 6 10,000s. And for question number 5, the underlined digit is in the ones place, and it's, well, 1. So 1, 1. Last question. It's 2 in the hundreds place, so it's 2 hundredths. Now that we're done that, let's move on to the next section. So remember that 4-step plan that we talked about in section 2? Well, we're going to talk about it more. Twain baked 36 muffins for a class picnic. Cool. I mean, we had potlucks, but not really picnics. Well, actually, no, we did have this graduation picnic. I didn't go. Anyhow, his dog ate some of them. Okay. And now Twain only has 31 muffins left. How many did his dog eat? So what do we know? We know that the initial number of muffins, or the number of muffins he started with, was 36. We also know that this guy is named after a famous author, but unimportant detail. And we also know what he has left. What do we need to find? Since his dog ate the muffins, and he didn't eat any of them, nor did anybody else eat the muffins. What do we need to find? Essentially, it's a difference between the initial number of muffins that he has, or had, and the muffins that he has now. Now our plan is going to be, again, math with all capitals, because it's just that important. And besides, this is a math class. Anyhow, step 3, carry out our plan. Well, 36 minus 31 is 5. His dog ate 5 muffins. Is the solution reasonable? I mean, yeah, depending on the size of the dog. If it's a Chihuahua, then I'd be surprised if it ate 1. But if it's something like a Golden Doodle or a Great Dane, German Shepherd, one of the bigger breeds, Tibetan Mastiff, I wouldn't be surprised. Reread the problem to make sure that we got our facts straight. Twain baked 36 muffins for a class picnic. His dog ate some of them. And now Twain only has 31 muffins left. How many did his dog eat? Well, we got our facts straight. and our calculations are correct, how can we check our answer? We could, well, redo the problem. Or we could do the problem a different way. But honestly, are you going to draw out 36 muffins and cross out 31 of them and count whatever's left? I mean, that would take a while. Even if you're just drawing out 36 circles. But that'd still take a while. So, yeah, that's it for this section. Now we move on to the next one. We move on to comparing numbers, such as which is greater, which is less. Which number is less, 823 or 832? You do not actually need models as in the cubes and the blocks. This is how you would usually go about comparing numbers, or at least if you want to do it quickly, on a piece of paper, or in your head. So you kind of line them up, and you see which one has the most digits. If they have the same number of digits, and no decimal points, guys. Decimal points, well, they kind of mess up the digit rule. Since all of these are whole numbers and you haven't really gotten to decimals yet, you're safe. Now, both of these have the same number of digits. So you start from the leftmost digit and compare those. 8 and 8, they're the same. So we move on. 2 and 3. Well, 3 is bigger than 2. So the one with the 3 is bigger. Everything else to the left of anything different can be omitted and you just don't think about them anymore. Therefore, 832 is bigger. Conclusion, 832 is greater than 823. Now we're going to compare a bunch of numbers and write greater than, less than, or equal to. 630. Oh, that just sounded like a time. 630. 559. It has the same number of digits, so we're going to start from the leftmost digit and 6 and 5. 6 is bigger than 5. Therefore, 600 something is bigger than 500 something. Specifically, 630 is bigger than 559. We move on. 182 and 289. Well, 2 and 1, which is bigger? 2 is bigger than 1. So 200 something is bigger than 100 and something. 182 is less than 289. 293 and 239. 2 and 2 are the leftmost digits. Those are the same, so we move one digit to the right. 9 and 3. 9 is bigger than 3. Therefore, 293 is bigger than 239. 762 and 199. We look at the first digit. Well, actually, no, we look at the number of digits first. And then we realize that for all these questions over here, they're all 3 digits. So we can't go with that strategy. We look at the leftmost digit, 7 and 1. 7 is bigger than 1. Therefore, 762 is bigger than 199. Essentially, you're just comparing the place values that have the biggest value. Okay, that sounds strange now, doesn't it? You're comparing the largest place values, and since, well, the smaller ones are on that side, you naturally start with the left. Okay. 192 and 921. So we look at the leftmost digit, and we get 1 and 9. 1 is smaller than 9. So 192 is smaller than 921. Question number 6 has 909 and 909. Well, all the digits are the same, and they have the same number of digits, and all the digits are also in the same order. So these two are just equal. Hey, I'm just going to write the equal sign like that because, hey, guess what? There's already a line there for me. Nice. 214 and 241. Leftmost digit, 2 and 2, they're the same. 1 and 4, they're not the same. 4 is bigger than 1, so 214 is smaller than 241. 852 and 855. We look at the leftmost digit, 8 and 8, they're the same. We move one digit to the right, 5 and 5, they're still the same. We move another digit to the right, and we get 2 and 5. 2 is smaller than 5, so 852 is smaller than 855. Remember guys, you can take a break at any time during the video, because doing practice problems and absorbing information is a very important thing. I see you have decided to continue, or decided to come back. Hi. We're going to take comparing numbers one step further and go with ordering numbers. A box has 524 bags of marbles. Alright then. 719 bingo games and 644 checkers. What are you doing with this box? Where did this box come from? A warehouse that stores marbles, bingo games, and checkers? Okay, anyhow. Although this is a little strange, but then again, this is a math problem, the only place where a person can go ahead, sit down, and eat 74 apple pies in one sitting, but hey. Order the numbers from greatest to least. Now, we still compare them in the same way. It's just that there's more numbers. So there's 3 numbers, and all of them have 3 digits. We start with the leftmost digit of each number. It's 5, 7, and 6. 7 is bigger than 6, which is also bigger than 5. Well, I guess we have our answer. 719 is the greatest, 644 is the next greatest, and 524 is the least. Okay. We're going to do some practice problems. Order the numbers from least to greatest. It's least to greatest now. Here, all the numbers have 4 digits. And all of them, the leftmost digit, is 4. So we move on to the second leftmost digit, and we get 8, 2, and 6. 2 is smaller than 6, which is smaller than 8. That's our order. 4,261. And then, okay, this is why some countries don't use the commas. Because when you're ordering numbers, the commas get a little bit wacky. So I'm just not going to use commas anymore. 4,674. And then it's 4,826. Not using commas for every 3 place values is not incorrect. Just saying. Anyhow, question number 2. It's still, all of them are 4 digits. All of them have the same leftmost digit. We move on to the next leftmost digit. And we realize that that's also the same because it's 3, 3, and 3. So we continue and move one more digit to the right, and we get 4, 3, and 0. All right then. So 4, 3, and 0. 0 is smaller than 3 is smaller than 4. The first one would be the one with the 0. Well, with the 0 in the tens place, because the thousands and the hundreds place, where all of them are the same. And then it'd be 5,330. Then it'd be 5,343. From least to greatest. Question number 3. The leftmost digit is once again the same, and once again we have the same number of digits for, well, each number. We're going to move on to the second leftmost digit, which is a hundreds digit. There's 7, 5, and 0. 0 is smaller than 5, is smaller than 7. Therefore, 7,075 is the smallest, 7,570 is the next smallest, and 7,705 is the greatest. We move on to the next set of practice problems. Order the numbers from greatest to least. We're going back to greatest to least. Okay then. So, here's the thing. All of these have the same number of digits and have their leftmost digit in their set the same. And all of these are in the thousands, so the second leftmost digit for all of these would be the hundreds. We're going to compare the hundreds place, and we get 7, 9, and 5. 9 is bigger than 7 is bigger than 5. Therefore, 1,932 is bigger than 1,784 is bigger than 1,512. If you really want to think about it with models, then think of it like this. All of these have 1 thousandths cube. So you can't really compare them on the thousandths cube. But they have different numbers of 100 blocks. And in case you haven't noticed, you can't exactly have more 10 blocks. Well, you can have more 10 blocks, but more 10 blocks in value than 100 block, because you can only have 9 10 blocks, because once it gets to 10 10 blocks, then it's 100 block. Therefore, that's why we go from, well, left to right in place values. It's the greatest place value, well, the greatest place value with the greatest value. Well, that's a mouthful. Anyhow, moving on. 9,000, 9,000, 9,000, so we're going to move on to the hundreds. 600, 100, 500. Oh, 500. 6 is bigger than 5 is bigger than 1. So 9,634 is the greatest, 9,508 is the second greatest, and 9,197 is the least. It's the last and the least. Now for the last question of the section. Not time to slack off yet. They're all 8,000. So we're just going to ignore the thousands. We move on to the hundreds. 800, 200, 800. Okay, so 2 is smaller than 8. So the 200 one, the one with the 200, is the least. But which one of the 800s is greater? Well, we move on to the tens place. And we see 2 and 0. 2 is bigger than 0. So the number with the 800s and the 2 tens is the greatest. And then it's the 800s with the 0 tens. And the one with the 200 is the least. Well, that's that section. Now we're going to move on to rounding. Specifically, rounding to the nearest 10 and 100. Well, tens and hundreds. You can use a number line to help you round numbers, or you can choose not to use one. Essentially, when you're rounding numbers, you look at what number it's closer to. And if it's right in the middle, you round up. Here's how you would look. So if you round 159 to the nearest 10, then you would look at the tens place and then go to the right, one digit, which is the ones place. You look at the ones place, and if it's 5 or bigger, greater than or equal to, this is the sign for greater than or equal to, 5 equals round up, smaller than 5 equals to round down. Sometimes in science classes, in advanced science classes, there will be more rules on how to round, but right now, this is how you round. And usually for most of math, this is how you round. So what's the ones place? It's a 9. 9 is bigger than 5. Therefore, we round up to 160. Now, how would we round to the nearest 100? Well, what's the place value 1 right to 100? Tens. We look at the tens place, it's a 5. 5 is equal to 5, so we round up. And we get 200. Because when you round up from 100, you get to 200. Since rounding is how close something is to an anchor. And fine, I'll draw a rough number line over here. So this is 100, this is 200, and this is 159. So this 159 is slightly closer to 200. That's what it means to round up. But what if it's something like 130? Well, you round down because it's closer to 100. We're going to do some exercises. Round each number to the nearest 10 and nearest 100. 357. How would we round that to the nearest 10? Well, we look at the ones place, and we get, well, the ones place is a 7, and 7 is bigger than 5. We round up to 360. What about the nearest 100? Well, we look at the tens place, which is a 5. 5 is equal to 5. We round up to 400. Now there's 263. If we round to the nearest 10, we look at the digit to the right, which is the ones digit, or ones place, and we get 3. 3 is smaller than 5, so we round down to 260. What about to the nearest 100? I mean, the tens place is what we look at for the nearest 100. Now what's the tens place here? 6. And 6 is bigger than 5. We round up to 300. $521. If we round to the nearest 10, we look at the ones place. The ones place is a 1. 1 is smaller than 5. We round down to 520. If we round to the nearest hundreds place, then we look at the tens place, and the tens place is a 2. 2 is smaller than 5, so we round down to 500. Since 521 is closer to 500 than it is to 600. Continuing swiftly on, we get 858. If we round to the nearest tens, we look at the ones, and the ones place is an 8. And 8 is bigger than 5. We round up to 860. What about to the nearest 100? Well, for the nearest 100, we look at the tens place. The tens place is a 5. 5 is equal to 5, so we still round up. And that's to 900. 719. For the tens place, we look at the ones place. The ones place is a 9. 9 is bigger than 5. You round up. to 720. For the hundreds, well, the nearest hundred, you'd get, well, you look at the tens and it's a 1. And 1 is smaller than 5. You round down to 700. The last question of this section, not time to slack off yet, is 442. For the tens place, well, the nearest tens, we look at the ones place. And the ones place is a 2. 2 is smaller than 5. Therefore, we are going to round down to 440. For the 100, well, we look at the tens place. The tens place is a 4. And, well, it's a 4. 4 smaller than 5. We're going to round down to 400. We're going to move on to even more rounding. Rounding to the nearest thousands really isn't that different, since all rounding works on the principle of looking at the place value you're supposed to round to and then going one place value to the right and looking at that to decide if whether or not you round up or down. You can use a place value chart to help you round numbers. Round 1,596 to the nearest thousand. So we're rounding to the thousands, and we move one place value to the right, and that's the hundreds. Now the hundreds is a 5. 5, well, you round up for 5. Now that would mean that 1,596 rounds up to 2,000. If you think about it, this number is closer to 2,000 than it is to 1,000. It's 596 away from 1,000, but it's only 404 away from 2,000. We're going to do some practice problems. As usual, round to the nearest thousand. For the nearest thousand, you would go 1 to the left, so you would look at the hundreds places. Oh. Anyhow, this is a 0, and 0 is smaller than 5. We're going to round down, which means that we're just going to keep the value for the thousands and change everything else into 0. Well, everything else as in everything to the right. Question number 2, the hundreds place is a 5. For 5, you round up, which means that we're going to increase the thousands place by 1. And we get 9,000. For question number 3, the hundreds place is a 7. 7 is bigger than 5. We're going to round up, which means 3 plus 1, 4. 4,000. Now, we're going to abandon or leave behind the place value charts. We're all rounding to the nearest thousand, and we have 9,489. You don't even need to pay attention to the 89. You look at the digit you're supposed to round to, the thousands. You go 1 to the right, the hundreds, and you see that the hundreds place is a 4. 4 is smaller than 5, which means that you are going to round down to 9,000. And moving on to question number 5, you get 3,120. Again, you look at the thousands place, which is what you're supposed to be rounding to. You go 1 to the right, and you get 1 for the hundreds place. 1 is also smaller than 5. So you round down again to 3,000. 8,711. Well, again, look at the hundreds place. It's a 7. 7 is bigger than 5. You round up to 9,000. Now, I know you might be asking me, what if it's something like 9,872? Well, you look at the hundreds digit, you realize that you have to round up, so you increase the thousands place by 1, and you end up with 10,000. Yeah, that's just how it works. But now that we're done with that side note, 5,102, you look at the hundreds place is a 1, you round down because 1 is smaller than 5, to 5,000. 4,766, well, you look at the hundreds place, it's a 7, and 7 is kind of bigger than 5. You round up to 5,000. 3,439, well, it's, the hundreds place is a 4. And 4 is kind of smaller than, well, 5. So you round down to 3,000. That's it for chapter 1, kids. I'll see you next chapter.